All right, from the 2016 AP Calculus BC free response, question number 4. Here is another good question that involves a lot of different topics, which is a great example of how AP might mesh topics into a single question. Okay, so, and you're going to continue to see these from like 2016, 2017, 2018, 2019, so keep your eyes open. Part A asks for the second derivative in terms of x and y. If you guys take note, my first derivative is in terms of x and y, which means that I have to take the second derivative implicitly. Okay, so we're going to take the second derivative implicitly. So the derivative of the first derivative is the second derivative. And then the x squared is 2x minus the derivative of 1/2 of y is 1/2. Hey, I just took the derivative of y with respect to x. dy dx. Okay, which then it says to write it in terms of x and y. I'm going to now have a 2x minus 1/2 times dy dx is this. So x squared minus 1/2 y. Okay, and that's all I'm supposed to do here. Moving on to part B. Part B wants to know if f has a max or a min at this particular point, -2, 8. And the very first thing that has to be true in order for me to have a max or min is my derivative either has to be 0 or my derivative has to not exist, meaning I have a critical point. And this is my derivative, and there's nothing I can't plug in for x or y, so it should be defined for all real numbers. So my question is my derivative equal to 0 at the point -2, 8? Okay, and so the derivative is defined as x squared minus 1/2 y, so x squared minus 1/2 y, and I'm getting I have to go through this because I need to know, is this a 0? I get 4 minus 4, which is 0, so that's my first step. Okay, so I have a possibility of a relative min, a relative max, or neither. I don't know if I have a sign change in my derivative. Okay, do I have enough information to make a sign chart for the derivative? Well, let's look at the derivative. The derivative looks like this, x squared minus 1/2 y. You can't make a two-dimensional sign chart. Okay, so what is the backup plan for when I need to know if I have a local max or a local min, but I can't do a sign chart? And hopefully, if you think about it, the backup plan for when you can't find whether something is you have a horizontal tangent, but you don't know if it's a max or a min because you can't do a sign chart, is to consider the concavity of the graph. If my graph is concave up, then I have a local min, and if my graph is concave down, then I have a local max at that point of horizontal tangency. So the next thing I'm going to need to consider is what is the value of my second derivative at this same point, -2, 8. And my second derivative is right here. It's, well, actually, I'm going to use it right here because that's fun. It's twice x minus 1/2 dy dx. And dy dx at this particular point is 0. So I don't have to re-plug into all that nastiness. I just got a negative value here. And because this is a negative value, I'm going to say that f is concave down. Right, and because f is concave down, this is what I've got going on here, and concave down horizontal tangent means that I have a local max. Okay, and that's part B. All right, let's move on. Okay, looking at part C, it says G is the particular solution to the given diffie-q. You guys see it doesn't say at any point find the solution. If I look at the diffie-q, I can't even do separation of variables on this, so something's up here. So my very first thing is I'm just going to check my limit. Okay, so if I plug in -1 here, I'll do it over here. If I plug in -1, I'll have g of -1 minus 2 over 3 times -1 plus 1 quantity squared. And g of -1, well, they actually just told me is 2, so I have 2 minus 2 over 3 times 0 squared. So I get 0 over 0. Okay. Anytime I get 0 over 0, I got to do L'Hopital's. But I got to give AP what AP wants in order to do L'Hopital's. So what I'm going to have to do is I'm going to have to state the following. Because the numerator and denominator are continuous, that's the very first thing you have to get out. And then, and I know that this is silly, okay, and this is really silly because we showed that they're both approaching 0, but you now have to say, and because the limit as x approaches -1 of the numerator of g of x minus 2 equals 0, and the limit of the denominator, the limit as x approaches -1 of 3 times x plus 1 squared also equals 0. You need to show them separately. I don't know why. I can't tell you it's what AP wants, so don't complain about it. Okay, we're just going to put it on your quick review sheet. So you state that both the numerator and denominator are continuous, and that each individual limit is 0, and now I'm going to say that I'm going to use L'Hopital's. Okay, so I'm telling them I'm going to use L'Hopital's, so my L'Hopital's is going to be the limit as x approaches -1 of the derivative g of x minus 2 is just g prime of x. The derivative of 3 times the quantity x plus 1 squared is drop down the exponent, becomes a 6, reduce the exponent by 1, the inside stays the same, times literally the inside would just be another 1. So this is going to be now g prime of -1 over 6 times -1 plus 1. Okay, so now I see my denominator is still 0. Okay, I need my numerator to still also be 0 in order to L'Hopital again. If my numerator is a number, I'm talking about a vertical asymptote blow up discontinuity. Okay, so g prime of -1, I'm going to calculate by going back up to what g prime is. G prime is dy dx, okay? Because y equals g of x is a particular solution to this right now. And so I have the point, where is it, -1, 2. So dy dx at -1, 2 is going to be, that is my g prime of -1. And so I'm going to be doing -1 squared minus 1/2 times my y, so times my 2, and I'm getting a 1 minus a 1, which is a 0. So guess what I get to do? I get to do L'Hopital's again. All right. Okay, so I'm going to repeat L'Hopital's. I honestly don't know if you need to state all that stupid stuff again. You don't need to say that it's continuous. I don't know if you need to show that each individual limit is 0 again. I might just restate both of those things. So. Okay, so just repeating it again, because the numerator and denominator are continuous, and the limit as x approaches -1 of the numerator, which is g prime of x is 0, and the limit as x approaches -1 of the denominator, which is 6x plus 1, also equals 0. We're going to use L'Hopital's, and I'm going to have the limit as x approaches -1 of the derivative of g prime of x, which is g double prime of x, over the derivative of 6 times the quantity x plus 1, which is just a 6. Okay, now my limit as x approaches -1 of g double prime of x, we found in part, oh goodness, it was part A, that my second derivative was equal to twice x minus 1/2 dy dx. So my second derivative at this point, which is the point, what is it, -1, 2? Is going to be twice x minus 1/2 dy dx, and what we found for dy dx at that last point was 0, so I'm getting a -2 now. Okay, and that is my answer. Okay, I do get that it's a pain in the butt with what we have to write out for the L'Hopital's rule, but better safe than sorry. Put it on the front page of your quick reference sheet, and you'll have it, and you'll just know what to write. All right, let's move on to part D. Part D wants us to use Euler's method. So I'm going to start with my initial point. I have my point 0, 2. Okay, and so my initial y is 2. My new y is going to be my old y plus my step size times my slope at my previous point. So my step size right now, I'm going from 0 to 1. Okay, so that's in a positive direction. So my step size is going to be a positive 1/2. Okay, times my derivative at the point 0, 2, which is going to be 0 squared minus 1/2 times 2. Okay, some of you guys are not simplifying this, some of you guys are simplifying this. At the very least, you need to write this as 2 plus, I don't know, I would write this as a 1/2 times a negative 1. You want to just at least clean it up a little bit, just so that you can, because some of you guys are not simplifying your work when you're doing this. If you want to simplify it, it would look like 2 minus 1/2, which is 3/2. Okay, and then, so now I have the point, my x I just increased by my step size, which is 1/2. So I went from 0 to 1/2. And my y value, some of you guys leave as, I'm just going to put in a 3/2 here, but it's okay to have here the 2 plus 1/2 times negative 1. Okay, so now my new y, we just said, was 3/2. So the next y, which is the one that I want, is going to be the old y plus my step size, which now I'm going from 1/2 to 1, so it's still just 1/2, times my slope at this point. And my slope at that point is given by x squared. So x squared minus 1/2 times y. And I don't know, I've got all mixed up fractions and decimals. It doesn't even matter. But I'm just going to leave it like this. Okay, and it's okay if in here, instead of having the 3/2, you had that little expression in there. That doesn't affect anything. Okay. Excuse me. So again, it's a problem that covers a lot of different topics. But each of them aren't that bad. You just kind of have to be good with the stuff that just feels uncomfortable. Get over the fact that it feels uncomfortable and just get through it.